So, okay, we already know what is a SQL, and I'm going to keep you unmuted because you know that. So, if you want, you can just jump in. What is SQL and all that we kind of talked about yesterday. These slides are actually what I should have had yesterday. It's just that I didn't have access to my folder yesterday. I got it at today. So, anyways, all this we kind of know. Database, what is database, and all that stuff. Uh, and then some basic stuff about SQL, like it's not case sensitive and so on. We covered that yesterday. So we covered a lot of this stuff yesterday. I'm just going to jump through the slides, and these slides have different examples. But I sent you in the meeting space the examples from yesterday. So you can basically use that and build your own examples or whatever, or you can create your own tables and do your own examples. So SQL statements. I was talking yesterday about DML and DDL. DML of course is the data manipulation, and DDL is data definition. And basically DML is like select, insert, delete, whatever, and DDL is like create, drop, stuff like that. So okay, select statement we covered yesterday. So I'm just going to jump through the slides until we get to the points of unions and intersection and joins. Select we covered, insert we covered, delete, update. The in operator we didn't cover yesterday, but it has basically allows you to select values within like you can specify it like this: select column name from table name, and then where column name in, and then you pass multiple values over. So for example, like here we have in this example, this is your table, and this is what you're passing two values, and it checks for those with this in operator. It's more or less like between. The results might be different, of course, and okay, and we'll just join. So let me mute you. Okay, and between we covered yesterday. Of course, and these are data types. Like this is a little bit longer list of data types in SQL. And of course, in different types of SQL, I have just kind of written down what is the name for the data type in that type of SQL. This is just for reference, and tells you what each data type is. In these, like kind of information is stored in these data types. Okay, so moving on, aggregate functions we have not covered yet, but we will maybe cover it later. But aggregate is used to basically get some kind of aggregation, like sum or count, like count how many number of records are there. So for a certain select statement, we can have a sum or a count or an average, stuff like that. We can find minimum, maximum values. So those are some of the basic aggregate functions. And basically in aggregate functions, the null value, and null value, we'll talk about that quickly right now. It will be on the slide though. Null value is basically that there is no value. Okay, so null value doesn't represent anything. It's not 0, it's not 1, it's not -1. It's just that it's not a value. So null values don't your aggregate functions in general, except for the count function, because the count function actually counts the number of records. So even if you have null values, you will still probably see it in the count. So if you write a query to separate the null value out, then it would obviously come in. So you basically the way to take it out would be to write a query and ignore the nulls. Okay, group by function we covered yesterday, and this is just group by null. We said null is not a value. Comparison operators in keywords. Basically, comparison operators, of course, like if you want to write some kind of statement, wherein you are comparing two values, then you can use these operators like greater than, less than, greater than equal to, less than equal to, and so on. All right. Of course, we also have these keywords which we use, like, between, in, exists. Precedence of operators, well, it is dependent on the type of SQL you will be using. Oracle, there is no particular order. SQL Server is left to right. Of course, you can use parentheses to define the order. So more or less, if you use parentheses, you can control what is done first. Now let's get to the real meat of today's class, which is set operation and then followed by joins. Now I don't know if any of you remember, but in mathematics we had a topic called sets, okay, and then we had basically two different or maybe more than two sets of let's say numbers or data, and then you're performing some kind of operation on it. Now there are two obvious, and if you remember your sets, there are two main types of operation. One is union and one is intersection. Okay, now union basically is combining or uniting the two different data sets, and intersection is basically finding where they intersect, as in what is common between the two. So basically finding the common data between two or let's say more different sets. Okay, all right. Of course, and in SQL you're always doing let's say if you're doing union, you can do union of obviously two sets or more. Okay, so you need to have multiple select and union statements, and you can also have multiple intersect statements with multiple select statements. But generally, of course, obviously, when it comes to intersection, you can intersect one with another, and that result of that these two would be intersecting with the third one, basically. So, anyways, so I guess now by looking at these figures on the right, maybe your memory might then be to refresh what sets were when if you had sets in mathematics in school. And if you see on the figures on the right, there's two gray circles. One is called query 1, one is called query 2. Okay. Now, for a moment, assume that query 1 and query 2, of course, in the figure it shows union and intersection. But for a moment, assume they're two separated and like, let me just do it like this. So for a moment, assume that you have two sets, okay, and you have let's say one, and then you say you have two, okay. So, oh sorry. So anyways, those are two separate query 1 and query 2, and what you have is two different sets of data. So what happens with union, and this is what happens with union, okay. When you have two sets of data, okay, and when you do a union operation, you're basically combining all of the data, okay. You're combining all of the data. So all the records, and when I'm saying this, you're combining all of the data. Now, why query 1 and query 2? Because you're combining the result of two queries, basically. So basically, you will have query 1, which is, let's say, select star from a table called, let's say, persons, okay, and let's say our query 2 is select star from say table accounts. Now obviously you have two different sets of results from both the queries. So how do you combine the results of this? By using the union operation in this case. And when you use the union operation, basically the results of query 1 and query 2 together, if all the data, okay, is combined minus any duplicates. It will not show duplicates by default, okay. If you want to see duplicates, you will do union all, okay, and this is basically what you will do: select star and then union and then select star, or whatever, select column name from table name, and where. By using where, you're specifying a condition. And of course, like I was telling yesterday, you don't obviously want to use select star, you just want to be very specific in your query. So you mention select whatever column names, and you also just don't leave it at from table name. You also specify conditions. So you have limited set of records which are being displayed in your query result. Now, what is intersect? Intersect is basically common ground. Okay, and I'm saying that in the normal sense. Okay, intersection is basically, if you look at it, this is an intersection of the results of the two queries. So query 1 has these results, query 2 has these results. This is where the data overlaps or it is intersecting. So only that data is selected in intersect. Okay, all right. Now these are the two main types of set operations, and of course you can combine them in any order and have multiple select statements. So you can have, let's say, select one query and then union, and then second query select whatever you have, and then you can have another union and another select statement, or you could have query 1 select something, then intersect, and then you can have another query select and something else, and then you can have another intersect and you can have another select statement. Now this is only for union intersect, but it is also possible to do select and then union and select and then intersect and then select. Okay, or vice versa. You can have select, intersect, select, union, and select. And when I'm saying select, I'm referring to the whole query. I'm just saying select in short. Okay, don't think that I'm just saying select and then select like that. When I'm saying select, it's the whole query. All right. So this is how you basically combine your, I just said that. All right. Now in union, obviously by default, like I said, you will have total all records will be shown minus the duplicates. Okay. And when you're doing a union, both the statements should have same number of columns for the union to happen. Okay. All right. And then we have mathematical operations. Mathematical operations we don't normally use in general QA use, but there are few mathematical operations available like absolute, round, square root, sine, floor, sine, cos, tan. That's trigonometric functions. I hope you are aware of these from mathematics. So I'm not going to talk into detail what they do because they are self-explanatory. Okay. Okay. Now let's get to joins. Now what are joins? Now remember what we just did with select and intersect. Well, we can basically combine and intersect data from tables, using select. Union and intersect operations. But that is not the most, I should say, that's not the most cheapest. I shouldn't say cheapest. I should say, if you use joins, you are using the system more efficiently. Yeah, that's the right word. When you use select, union and intersect, you don't necessarily use the queries and the resources of the system efficiently, but you can achieve that with joins. Okay, and joins is very popular. Especially when it comes to SQL, the first thing they will ask you probably in an interview, even before they probably ask you, what is SQL, they will probably ask you what is a join. Okay, so it's basically join is used to combine, data from tables. Okay, and you can combine, of course, two or more tables from maybe two or more databases also. So it really depends. So basically combining data from two tables or more. All right, and of course to do that, you are again still using queries. Okay, so you will be using like maybe a select query, of course, to get your data, and then you're getting data from the other table using another query. So another select statement, and then you're doing join. Okay, now for the joins, one of the things which you might need is to have a primary key. We already discussed what a primary key is yesterday, and a foreign key also we discussed yesterday. Okay, so let's get to what types of joins there are. There are actually different types of joins. These are some of the most okay, and we'll go through the other ones. So join basically joins, at least one match is there from both the tables. Then there is something called a left join, which basically returns all the rows from the left table, even if there is no match with the right table. Okay, and then nothing will be displayed from the right table if there is no match. If there is a match, it will show all the matching rows and whatever is remaining in the left table. And when I'm saying left table, that means the table which is mentioned in the query on the left. Okay, it doesn't mean that the table is placed on the left or right side. What Well, actually you can consider it in that way also, because the SQL statement which is coming on the left side is the left table, and SQL statement which is coming on the right side is the right table. So your left join returns all the data, so matching plus non-matching data from the left table. Okay, and the only thing from the right table it will return is the matching data. If there is nothing matching, it will still show all the rows from left table. Right join is exactly opposite. It shows all the rows of the right table, and then left table it will only show the matching rows. Or if there is no match, it will still show the rows on the right anyways. Full join of course shows all rows from both the tables when they are matching. Okay, then there is inner join and outer join, self join, and there's also cross join. Okay, so inner join is of course when you are joining two tables. The most simplest join is your inner join. Okay, only rows which meet the criteria, they are joined in the inner join. Outer join. Okay, in outer join there are three types of outer joins. There's outer left join, there's outer right join, and there's outer full join. Okay, and in the outer left you have basically remaining row from the left tables are returned along with nulls instead of actual right hand join tables. Okay, and so it's basically going outside of what needs to be matched. Okay, the right is obviously opposite, and the full is basically remaining rows from right and left is returned. Self is when you join a table to itself. Okay, that is why it is called a self join. Okay, and then there is a cross join where one is the Cartesian product, so it's from two tables. Okay, this is just the syntax. We'll just go through this now, and okay, so and we'll cover the examples. Subqueries are basically queries within a query. So basically, let's say you have a SQL query. Let's say select. Okay, and then within that query, you can actually have another query. Okay, so you can basically nest queries inside another query using parentheses. So what you do is you write a query and then you write another query inside it, and together basically you will get a combined result. Okay, and these are just different types of subqueries. Okay, let's see. So more or less like this. For example, you have select, you have the column name, and then you are using the aggregate function of the column name, and then you are saving it as store sales. Of course, you have to specify a variable when you are doing an aggregate function. Okay, so that's what we have over here. Okay, and then within the parenthesis, there's another column being added to this select query, and that itself is a query. So it's a query within a query. Okay, and then within that query itself there are two queries. So you can basically by proper use of nesting, like parentheses and using parentheses, if you place your subqueries properly, you can actually achieve better results. And of course, this is a little bit more complicated SQL. Well, it's not really complicated. It's just that you have to write it correctly. Otherwise, it's still a basic select statement, anyways. Now there's something also called a view. View is basically a virtual table, or you can just call it a view, as in like you can create a view to view certain records. Let's say you have a table with 20 columns, and normally you only use 5 of them. So when you view that table, you want to view only those 5 tables. How do you do that? You achieve that with views. Okay, So, or you could use some other criteria. That's just one example of why you would use a view. But there may be other situations where you may want to use view. So, view is basically creating a virtual table wherein you see only the data you wish to see based on maybe a certain query or certain criteria. Okay, and of course, those are just some of the reasons why you would create a view. And then you have different types of views like read only and update and so on. Okay, so and that's how you would create a view. We'll get into that. Well, actually, just it's similar to creating a table. The only thing is you have to specify query instead of specifying fields. Like as in, when you're creating a table, you specify the data type, sorry, column name, then data type, and then you keep on going, comma, comma, and within the parentheses. In create view, you're basically saying create view, and you give the name, and then you say as, and then you use the select statement and whatever condition you want to do. Okay, or you can specify a column list also and just whatever. So, and this is how you drop view, and that's also how you drop table. Drop is basically deleting the whole table, or drop view is deleting the whole view. All right. Okay, so we covered view. Okay, this is also another type of view, a little bit more advanced. So we'll just go through this to, let's see. Okay, and okay, so that's pretty much the basics of this. Now let's get out of here and let me close this. Let me come here. Let me open this. Okay, let's close this. Okay, and all right. So okay, so basically we're gonna start with the examples of joins, and this is the okay. So we already covered yesterday till insert, deleting tables. Okay, see, I just told you how we drop table. Okay, so what was the name of the table I created yesterday? My table name one, I believe that was the name. Yeah, so I can basically do a drop. Oh, okay, I have to mention table. Okay, because you have to tell what you're dropping. Okay, see, table dropped. All right, that means that table has been deleted. Now, if I do this, I should be able to see. See, it says object does not exist. All right, all right. Let's clear the screen. All right. So now let's do the set operations. And for set operations, let me see which tables I have. Person and employee. Okay. So select. Let's say star from. Let's look at our tables first. Okay. So we have person. It has PID and FName. Okay. PID is your primary key, and that's what it is. Character number, and then FName is character. And what is the other one? I guess employee. So that's your employee table. Okay. Now let's look at what we have in the person. Okay. So we have those records. Okay. And let's look at employee. Okay. I have so if you see, I have my name twice, and then Hari, and then Kanchan Rahul. 5 records. Okay, uniquely numbered. In the second table, I have the first 5 are same, and then 6, 7, 8, 9 is different. Right. Okay. All right. Now there's a bunch of things I can do with this. There's lots of different ways of working with data, and basically what will happen is when you do that, you will obviously see data in different ways. So that's why if you have to know how to write your queries. So let's say, of course, this is the simplest way to see the records from both tables. Okay, but what happens is now because of this statement, everything is being repeated, so on. I don't really like it that way. So what I can do, let's look at the next example. Okay, this is what we'll do. We will now do a union. Okay, syntax we already kind of covered in these slides. It's basically select statement 1 and then select statement 2. Okay, so we have our two tables. Okay, and you have here select, and you have the second statement. And what will happen is basically it will join the two tables. No, okay, let me correct myself. I shouldn't say join. It will union the two tables, and because joins are different, it will union the two tables and return only the non-duplicate records. So it shows, let's say 9 records because that's the only unique. And of course, if you remember, the total records in this is 5. Okay, and in this is 9. Okay, so it only showed me the total records which are unique. Okay, and it combined the two tables. Now I know you might question me that okay, these two look the same, so well, we can always change the data if you want and check that, but this is the correct one. Okay, when I was just typing the data, I just didn't pay attention to that. So now if you want to see all the records including the duplicates, and let me not type everything, let me just get the history. So that's okay, so you will say union all. Okay, now you see all the records are returned. Okay, so the union all does all records, and just union by itself just the matching records. Okay, alright, now let me clear this and just remember which records are there. So let's do a intersection now. So what happened? It only returned now the places where the two tables are intersecting, right? And I'm just showing the data to you again, so you can actually see the data and see it's only intersecting in these 5 records, so it returned only those 5 records. Okay, it didn't return the other records. So this is how the union operator would work. Now you can, of course, I also said combine data from multiple records, but sorry, multiple queries, or intersect data from multiple queries. So you can do a combination of unions and intersection. And of course, we use a very simple query, select star and select star from person. You can of course and ideally specify a where condition. Okay, not just for the first one, also for the second one. Okay, all right. So let's move on. Okay. Okay, that's just union. Okay, I just was telling you anyways, and this example is already here. If you want to look at it, you can look at it. But well, actually, let me do it anyways. What's the other table? Okay, AC table. Let me see if I have that table still here. Okay, I think I have it. Okay, and I guess let's do it because there's something different you can see actually. So let's do it. Okay, let me clear the screen here because I just realized you will see different results when you do different combinations. Okay, so select star from person. So that's what it is. Select star from employee, and this is what it is, and select star from ACT1 is what it is. Okay, so if you see here, of course these 5 rows are same, the rest is different, and this one has, of course, these are different, but 4 and 5 is also there in these two. Okay, so let's just say if I were to combine union and then select star from the employee, and again of course union, and then select star from ACD1. Oops. So it only returns to me unique records of the entire union. Okay, so 1 with 2 and 2 with, and the result of this with this. Okay, so it is basically unioning all these and returning only the unique records. Okay, which are and of course no duplicates. Okay, if I had done union all and union all, and of course now I have basically all the records including duplicates. Okay, now of course there's other possibilities when I'm doing stuff like this. Is, let's say instead of a union here, I had an intersect. Okay, now obviously table 1 and table 2 union had some, maybe 9 records, but the union of intersection of that with this is only a match on this 4 and 5 in the and if I go up, you can actually see 4 and 5 in the third query. Okay, so that's what I got. Now obviously I could also have a intersect here and 2 intersects instead of 2 unions. Of course both the tables, first and second, actually in this case you won't see a difference in data because first table and second table and third table all have the same page. But now earlier we did union first and intersect later. Let's do intersect first and union later. So obviously the result will be different because now you're doing intersect first and union later. So what is happening is intersect is happening between table 1 and 2. So it is going to just take 4 and 5. Okay, and then the result of that is being union with that. Okay, all right, and all the unique records of the 2 is going to be returned, and then you can do union all or whatever combination you want. So based on how you write your query and how you perform your operation, in this case set operation, union or intersect, your result may be different. Okay, okay, all right. Okay, so joins. Okay, so some of that theory is also on here, which I just put in the slides for you. Okay, so we have these tables, right? Now instead of doing set operations, what if we decide to do joins? And of course, the data is already showing on your right, it's the same data. I don't think I have deleted any records, so it is still the same. So you can look at the tables on the side and you can do the joins on the left side. So yes, okay, yeah, looks like the data is set. All right, so let's do the join. Okay, simple syntax, of course. You do select statement. So basically you have a query on the left, and then you do a join. Okay, and then you join on something. So syntax is select star from, let's say you could of course take column name or so select star from person, and then you say left join. Okay, and then you name the table. Okay, and then which field you are joining, what is your condition to perform the join. You have to, when you're doing joins, the reason for doing joins is specifying a condition in joining the tables based on that condition. So if you see on table 1 and 2, okay, you have F name and F name. Okay, and this table is account 1 and this table is person. Okay, what we are doing in this example is we are joining F name from table 2, table 2 with table 1 by specifying when table 2's F name is equal to table 1's F name. Okay, so and of course because we have the same column name, okay, and this is one thing to remember: when you have same column name, okay, you are basically specifying the relationship here by using the table name dot column name. Okay, so we are saying, okay, these two have to be equal. So on person dot okay, so what will happen in this case, because this is a left join, okay, so all the records for the table on the left, which is in this case the person table, should be returned, which is like this, and only the matching records from the second table, which is the right table, because this is a left join, will be returned. If there was no match, there will be nothing here. Okay, so that's exactly how it is. Now right join is basically the opposite. That's it. No change. I'm still using the same query. Just change it from left to right. So now you will see this has kind of transposed. Okay, and of course in this case, because the data is this 4 and 5 is same on both. The other data is different. Okay, that's how you can make out that the left join or right join is. And of course in real life you won't have repeated data like this. All right. Now what about other types of join? Now we had left, right, and full join. So we just changed it. And now if you see, you have all the records from the right table, all the records from the left table, and if you see carefully, the two rows which are matching are aligned. Okay, and everything else which is not matching is shown separately. All right. Now we have to look at inner join and outer join. Okay. This is just some examples of left join and right join. Okay. Okay, and let me see if I still have these tables. Let's just show the records. Yes, 9 records. That's correct. And I should have 6 records. Okay. All right. So of course we talked about an inner join. So the query is very similar. Okay. Select. You can of course do star or whatever. In this case, what I've done is, and again, the dots with the table names tell me or tell the query which column from which table you are referring to. You are defining the relationship of this column with that table using that column. Okay, that this column SQL has to find in that particular what you call table. All right, so and we are using one column from this table. We are using one column from this table. Okay, and then we are saying from. Why we did that is because you cannot obviously have two. Why we define the relationship here, because we cannot obviously have two table names here. Okay, if you had to do that, then you would have to write a subquery. Maybe you can write a subquery also. I just showed you how to write a subquery also. So from this particular table, okay, and then you're doing an inner join salary with the table. Okay, so you were specifying which table you're joining with, inner join, and then the name of the table. Unfortunately, my screen won't. I cannot change the size of the screen, so it will go to the next line. Okay, and then on. This is how you are going to specify the condition. Remember how we did in left join? Same way you are specifying the condition again here. On, what is the condition? The condition we are using in this case is where employee ID is equal to salary benefit, and of course we are using table relationships is same. Okay, so now if you see here from this table and these two tables, actually what you have here is, in this table you have 1 2 3 4 5 6 7 9. Okay, so that's the employee ID, and of course each employee has, whatever name. Now the other table has, of course, some salary ID and some salary return and some benefit return, and that salary or benefit or whatever it is that record has an employee ID assigned to it. Now ideally, and in this case of course I'm not using a foreign key. Ideally, of course, each employee will have one only one type of salary and benefit. This has two. Now that could possibly in some companies special situation, that's why I'm doing that. But in some situations where you are following a standard policy, you will basically have one line. In that case you will use foreign key. Okay, right now I don't have a foreign key sometimes, so I'm just specifying which employee ID has what benefits. Okay, so what it's showing is for employee ID equal to employee ID in the first table. Okay, because I don't have records for all the employees. I'm only going to see records for the employees whose ID has been added to the salary table. The other IDs are not present. Okay, of course, let's not get into the reason why they're not there, but they're not there. Okay, so 1 2 3 4 5, 1 2 3 4 5. So you got 1. Okay, so you have Shaheen and 0. Okay, and of course it's only showing these two fields because we specified those two fields, and it is basically doing a join from data from this table and this table. Now you could have probably achieved this with the union statement easily. It would have been a more very inefficient process, right? Because if you do union or whatever, then some things might not match, some things will match, etc. etc. So excuse me. So you have one here, you have one here, same match. Of course, then you have 2 3 4 5 6, and of course for each particular match, each record is brought out. So 1 Shaheen, there's twice. The salary is pulled from here. Okay, because that's the only thing I want to see. And then same way, my name, and then it pulls my name, and then it pulls my salary, puts it there. Then Hari, same way, and so on. Okay, so this is your inner join. Inner join is basically everything which is matching. It doesn't result into, like for example in the previous join, where in left join or right join or full join, you had records which were also displayed which were not matched. In this case, only the matching records have been returned. Okay, all right. Let's move on to the outer left, right, and full join. Okay, now same way, instead of this we do a, let's say, a left inner join. Instead of this inner join, we do a left outer join. Okay, so I change it to left outer join. Everything else is just the same, and then when I click enter, what happened now is everything which is matching, okay, is being returned, plus everything which is not matching is being returned from the left table. Okay, so similar to your left join. Okay, the right join is obviously the opposite of this. You will, well, it will only show the stuff from the right table which is not matching, and plus the matching fields. Okay, so well, actually we have all matching fields, so there is no extra fields left in the right table, so that's what we will see. But if I had more records which in the right table which were not matching, those would be displayed here. Okay, all right, and now the full outer join is basically showing me matched from both tables plus unmatched from both tables. Now right table, obviously, because it doesn't have any unmatched fields left, so we don't have anything there. but on the left table we do. Okay, all right. So that's your left outer, right outer full join, and then we covered left and right and full and inner join. Okay. Now the cross join is a partition product. Okay, it looks like someone either dropped or joined. Okay, all right. Let me mute that. Okay, all right. So this, excuse me, this is your cross join. Okay, it's basically a cross product. If you remember your mathematics, it's a cross product. Okay, and so your cross join is cross join, and you of course every time you do a join you put the name of the table. Okay, this is not a second query. Okay, all right. And when you are writing this condition over here, okay, when you're writing this condition over here, actually what you can also do is write a subquery. After this equal sign, for example, instead of this one, you could have written a subquery to maybe find something else, or whatever else. You know by now what a query is. So now, okay, let me, before I do that, let me show you both the tables. Okay, so you have 9 records here, you have 6 records here with bunch of data. Okay, and if I had written a cross join, what I'm doing, this is my condition for the cross join. Okay, of course, anytime you're doing a join again, I will reiterate, you have a condition. And like I was just telling you, instead of this equal 1, you could have written instead of 1 maybe another subquery. Oops, what did I do wrong? Oh, sorry. Okay, because I didn't name the field correctly. This is employee ID. I just wrote ID. So what it did is it did a cross product where employee ID is 1 with all the records of a this second table. So if you see it, okay, so you have all the records here, and it's a cross product. That's what a cross product is. Multiplication, right? If you remember your cross product, and your self join is basically joining the table to itself. Basically, the way you do that is you create an alias, and actually I don't have definition here what an alias is, so I'll show you what an alias is. An alias is basically using the same table. I will put it on the slide actually. Okay, alias is basically the same table, but you call it. Okay, actually let's not do that. That's too broad a definition. SQL join, self join, alias. What you will do, and let me while it opens, is when you do it. Okay. When you do a self join, how do you join a table to itself? Okay. Can I do this? Let's say I have a table. Okay, I have a table. Oops. Can I do this? Oops. Already ended there. No. Why? Because I'm trying to join the table to itself. I cannot. How do you do self join? Well, you have to create basically aliases or basically kind of copies. An alias is kind of a copy. Actually, yeah, that's what I was trying to find the word. Alias is a copy. So what you will do is basically to do a self join, you will create two copies, okay, and then you are joining the copies instead of the actual table, okay. And syntax for this self join is okay. This is okay. Wait, is like this. SQL Oracle SQL self join alias. Let's see. It should show it right here. You create a select statement and then you use copies, okay. See how you have copies of B and A. So what you will do, okay, I don't remember this accurately. Okay, I don't remember this correctly. This is how it is done. Okay, I have to actually see that and remember it. But it is more or less like this. Let's see. Actually, manager. Okay, it is not helping. Alright, I'll cover self join in a bit when I figure it out. I just don't remember right now. But because I never used it actually. But self join is joining the table to itself. So you create two copies, A and B, and then you join them. Alright, let's see what else we got. Self join. Select, select, select. We went all the way far up. Okay, so outer join, subqueries, subqueries. Okay, example of subquery. Well, I just told you can write a query next to the equal sign. So if you see this example I've done here, let me just make this page width. Okay, what I've done in this example is select star, and then instead of saying whatever number or whatever, I've written another query, okay, with some condition over there. So that's how I got that result. So subquery is just writing another query inside a query. You just have to make sure it's within these parentheses, okay. Alright, and you can of course also write a subquery here, okay. When you write a subquery here, where the asterisk is, it has to of course be inside the what you call parenthesis. And when you're writing a subquery here, the only reason why you would write a subquery here to do an aggregate function like sum, count, average, or something like that. And when you do that, you have to specify a what you call a variable name. Okay. If you don't know what a variable name is, read what a variable name is. It's about a little bit about programming. Okay, let's see what else we got here. Use, I just told you how to do it already. This is just an example of how to create a view, clear screen, and okay, that's okay. Let me. Why is it asking me this? It shouldn't. Don't save. Okay, let me clear this. Okay, what else we need to cover in SQL? I think as far as basic SQL is concerned, we've covered most of the. Let me exit from here, and there's something also called. You can also write complex queries. Now, let's see if I can find a few examples. Because we did very simple queries. Mostly you will be doing simple queries only. But let's see if we have any complex query I can show you, wherein you write multiple queries in the same line. Okay, this is not what I'm looking for. Oh, and then you can do stuff like even number, odd number, all kinds of stuff. returning the top 5 results, the top 10 results. There are lots of things you can do with SQL. It really depends on what exactly you're doing. So I'm just trying to see. Uh, okay, these are, see, we covered queries like these, so even these are somewhat complex. In fact, this is a little bit more complex. Like for example, let me just make it size bigger. See, in this example, for it, what you have is select and then table name dot column name comma table name dot column name comma, and then there's a count. Of course, count is an aggregate function, so when you say count star, it is basically counting all the number of rows. Okay, and then of course there's a max function, and then max function is being done on ads dot posted and classified as a variable, and then of course from, and then you specifying the table, and then you're specifying where, and this is your condition to do the of course select statement, and then of course you have group by and order by. So a little bit more complex query, but not too complex at this moment. Let me see if we can see any more. See count, max, we just saw that. Let's see what else we can see. See, this is where you have like comparison written in the query. You have, of course, whatever query you have, and then you have the more. You normally have where something is there, where you put a variable, and then, but now you have this not exist, and you're writing a condition, and within that condition you actually have another select statement. Okay, and you're combining this result of this by using the AND statement and giving another condition here. Will normally we use equal signs in our examples, but there's of course greater than, less than, not equal to, less than equal to, etc., etc. So you can also use those, and then you have group by or order by. So just to give you an example, queries can be very complicated. If you, and of course the more complicated the query is, you have to be careful while writing it, and of course your result will be more efficient versus just writing select star all the time. So okay, so I guess that pretty much wraps up the SQL. I'll just give you the syntax of SQL and I'll give you the example separately because I don't remember it right now. And honestly, it's difficult to remember. There's so many different SQLs. I just keep forgetting the format of this self join. But the concept is that you create two copies and join them. All right. And okay, so we've covered most of SQL. Tomorrow is Wednesday, and we can have a class